Let's dive right into this explainer and track the incredibly complex, perfectly synchronized anatomy required to get a delicious cheeseburger safely from your lips straight down into your esophagus. We do it dozens of times a meal, completely unconsciously, but the neurological and muscular ballet required just to take a single bite of food is absolutely staggering. We're going to break down the anatomy, the muscles, and the precise neurological triggers that make eating possible. To do this, we'll follow the chronological journey of our food. We'll start with the anatomy of a bite, talk about containing the food, making the bolus, protecting the airway, and decoding the final swallow reflex. And along the way, we're going to unlock the 5 essential cranial nerves that make all of this happen. All right, Section 1, the anatomy of a bite and the mechanics of chewing. The second that cheeseburger hits your mouth, we have to do some heavy mechanical lifting. Now, it seems like the simplest thing in the world, right? But have you ever stopped to actually think about the physical act of opening and closing your jaw and the specific muscles that power it? We usually just open, put the food in, close, and repeat. But anatomically speaking, the distribution of labor here is pretty surprising. I want you to clench your jaw right now. If you tense up, you can actually feel the masseter muscle right at your jawline. If you keep clenching and touch your temples, you'll feel the temporalis muscle working too. Well, here's what's really interesting. It takes 3 distinct muscles to close the jaw: the masseter, the temporalis, and the deeper medial pterygoid. But to open the jaw, just one. The lateral pterygoid literally does all the heavy lifting to loosen the mandible out of its joint so your mouth can open. Crazy, right? 3 for closing, 1 for opening. So the command center for all 4 of these chewing muscles is our very first neurological unlock, cranial nerve 5, the trigeminal nerve. Coming straight out of the brainstem, this nerve provides the motor function that powers your chewing. Interestingly enough, it's also a sensory nerve. If you touch your face, those sensations across the ophthalmic, maxillary, and mandibular zones are all being reported directly back to the brain by this exact same nerve. Moving on to Section 2, containing the food, essentially sealing the exits. Now that we're actively chewing, we face a highly practical new mechanical problem, keeping the food from just, falling right out of our mouths. To keep the bite contained, we have to lock the doors. First, the orbicularis oris, the muscles of your lips, lock the front door. At the exact same time, we tense the buccinator muscles in our cheeks to keep the food pushed centrally, right toward the teeth. And this perfectly illustrates the role of our second unlocked nerve, cranial nerve 7, the facial nerve. This is the motor nerve responsible for sending the precise signals that tighten up those lip and cheek muscles. Without cranial nerve 7, you literally couldn't keep your mouth closed while you chew. Oh, and fun fact, this nerve also carries the sensation of taste for the front 2/3 of your tongue. Meanwhile, inside this sealed-off environment, your tongue is doing some incredibly hard work. It has to constantly manipulate and move the food back onto the teeth so they can crush it. This tireless, continuous movement of the tongue is commanded by our third unlock, cranial nerve 12, the hypoglossal nerve. Okay, Section 3, making the bolus by moistening the food. Entirely dry food is nearly impossible to process or swallow safely. So, as we chew, our salivary glands jump into action. The sublingual glands under your tongue and the submandibular glands under your jaw are both triggered to release saliva by the facial nerve, cranial nerve 7. But what about the parotid salivary glands, located over near the ear? Well, those are stimulated by our newest addition, cranial nerve 9, the glossopharyngeal nerve. And just like nerve 7, this one also handles taste, specifically for the back third of your tongue. So, the crucial takeaway here is that through the combination of chewing with cranial nerve 5, containing with 7, tongue manipulation with 12, and moistening via 7 and 9, our bite of cheeseburger has officially transformed. It's no longer just food, it's now what we call a bolus. And once it becomes a bolus, the anatomical requirements of our journey change completely. Which brings us to Section 4, protecting the airway or preventing choking. We're finally ready to swallow. As the tongue contracts to push the bolus up and back, we enter a really dangerous phase where we absolutely must protect the windpipe. This happens through a rapid, sequential mechanical lift. First, the tongue elevates. Second, a group of muscles called the suprahyoid muscles contract. Try touching your Adam's apple and swallowing right now. You can physically feel this step happening. Those suprahyoid muscles are lifting the hyoid bone, pulling the entire airway up. Finally, as the airway is lifted, a lid called the epiglottis closes directly over it. Your airway is now completely sealed off. And finally, Section 5, the final swallow reflex.
the absolute point of no return.
With the airway safely guarded, the tongue pushes the bolus backward against the roof of the mouth. The exact split second that bolus makes contact with your soft palate, the glossopharyngeal nerve, cranial nerve 9, detects it. It acts like a tripwire, sending a massive signal to the swallowing center in the medulla of your brainstem. The brainstem instantly fires back a signal through our final vital unlock, cranial nerve 10, the vagus nerve.
The vagus nerve takes immediate control. It commands the muscles of the soft palate to contract, pulling it up and backward. This seals off the nasal cavity completely. Just think about what we've just achieved anatomically here. The airway below is blocked by the epiglottis, and the nasal cavity above is blocked by the soft palate. What used to be a shared compartment for air and food has instantly become a sealed food-only compartment. The bolus literally has nowhere to go but down.
And notice how beautifully this all pieces together mechanically. When those suprahyoid muscles lifted the entire airway up and out of the way to close it off, that sheer upward movement physically stretches the opening of the esophagus. The esophagus literally opens its mouth to perfectly catch the falling bolus, guiding our cheeseburger safely down toward the stomach. And it all happens in a fraction of a second. But as we've seen, it takes exactly 5 specialized cranial nerves, constantly communicating back and forth with the brainstem, firing in a perfect, rapid-fire sequence just to successfully execute one single swallow. So here's our final cast of characters. The trigeminal nerve powers the jaw. The facial nerve seals the lips and cheeks while providing saliva. The glossopharyngeal nerve adds more saliva and acts as the tripwire for the swallow reflex. The vagus nerve executes the final physical swallow by sealing the nasal cavity, and the hypoglossal nerve works tirelessly to control the tongue. It's a brilliant anatomical checklist showcasing how your brainstem orchestrates a highly complex physical ballet every single time you eat. Breaking it down like this really highlights the breathtaking complexity hiding behind our most basic human functions. It makes you appreciate the remarkable science hiding right there inside our everyday routines. And honestly, it leaves us to wonder, what other deeply hidden, totally unconscious reflexes are firing away, keeping us alive right now? Next time you sit down for a meal, try to track the journey of your bite. I promise you're never going to look at a cheeseburger the exact same way again. Thanks for learning with me today on This Explainer.